In this video, I will be solving the fourth part of the first problem of UPSC Civil Services Mains 2018 Statistics Paper 1. So let x1, x2 and so on xn be n observations, each independently uniformly distributed between theta minus half to theta plus half. We need to find a general form of maximum likelihood estimator of theta, and we need to verify that the given 2y1 plus 4yn minus 1 by 6 and 4y1 plus 2yn plus 1 by 6 are both MLEs, where y1 and yn are the minimum and maximum of this ordered statistics. So if I consider so we are having x1, x2 and so on xn, so they are i.i.d and they are following like uniform theta minus half to theta plus half. So that means like the PDF is fxi would just be 1 if our xi is in between theta minus half to theta plus half, or 0 otherwise. And since it is independently and identically distributed, so we can see like the likelihood would just be the product of this density function, so fxi, so that is nothing but, so it is 1 if our xi's are in between theta minus half to theta plus half, or 0 otherwise. So that means likelihood is 1 only if theta is satisfying this xi being in between theta minus half to theta plus half. So that means this theta minus half should be less than, so y1 should be greater than or equal to this theta minus 1 by 2. So that means theta should be less than y1 plus half, and on the other hand theta plus half, so yn should be less than this thing. So theta must be greater than yn minus 1 by half. So that means the theta hat should be inside, the MLE should be inside this yn minus 0.5 to yn plus 0.5. So therefore theta hat MLE, so the maximum likelihood estimator would be any value in between this yn minus half to yn plus half, y1 plus half, y1 plus half. So now like if we consider the given estimators, let's take theta 1 hat as 2 times y1 plus 4 times yn minus 1 by 6, and theta 2 hat as 4 times y1 plus 2 times yn plus 1 by 6. Now we can see this is nothing but 2 times y1 minus 0.5, or y1 plus 0.5 plus 4 times this is yn minus 0.5. So since we are adding 2 into 0.5, this we can write 2 into minus 2 into 0.5 plus 4 into 0.5 minus 1 by 6. So the same way 4 into y1 plus 0.5 plus 2 into yn minus 0.5. So plus 2 into 0.5 minus 4 into 0.5 plus 1 by 6. The same thing would be. So that means if we try to see, this is nothing but 2 times y1 plus 0.5 plus 4 times yn minus 0.5. So if we see this is becoming like minus 1 plus 2 minus 1, that means it is 0. So that means this is divided by 6. In the same way here as well, it is becoming plus 1 minus 2 plus 1, so that means it is becoming 0. So that means it will just be 4 times y1 plus 0.5 plus 2 times yn minus 0.5 by 6. Now, so that means like this is nothing but 2 by 6 into y1 plus 0.5 plus 4 by 6 into yn minus 0.5, and this is nothing but 4 by 6 into y1 plus 0.5 plus 2 by 6 into yn minus 0.5. Now we know like if we are having a closed interval xy, so lambda times x plus 1 minus lambda times y, suppose like lambda belongs to 0 to 1. So lambda times x plus 1 minus lambda times y, this is always in between x and y. So that means this estimators theta 1 hat and theta 2 hat, they are always lying in between yn minus half to y1 plus half. So since they are always inside this interval, and we have seen like theta hat MLE is the maximum likelihood estimate of this theta, estimator of theta, is any value in between yn minus half to yn plus y1 plus half. And we have seen like theta 1 and theta 2, theta 1 hat and theta 2 hat are in between yn minus half to y1 plus half. So that means they will also be the maximum likelihood estimates. So therefore, we have verified this 2n minus 2 times y1 plus 4y1 minus 1 by 6 and 4 times y1 plus 2yn plus 1 by 6 are both maximum likelihood estimates. So that's it for this video. We'll meet in the next video.